Hello there, and welcome to the Sleepy Space Channel. Most of the galaxies you can see tonight are already places you can never reach. Not hidden and not too faint, but carried away by the expansion of space itself, faster than any light or any ship could ever chase. Something close to 97% of the visible universe has already drifted beyond the edge of contact, sealed off by a quiet horizon that no signal will ever cross. The strange truth is that seeing a galaxy was never the same thing as being able to reach it, and for almost the entire sky, that difference has already become final. Over the next 2 hours, we will follow slowly how the universe we can see grew so much larger than the universe we can ever touch. If you find these quiet explorations worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next 2 hours, none of this is anything you need to carry. Let it all be far away and harmless. Settle in now and let yourself grow heavy. Let your shoulders soften. Let your breathing slow. Let the day fade gently away. Let's begin. There is a quiet fact about the universe that almost no one is told, and it is stranger than most of the mysteries that get more attention. Most of the galaxies you can see in the night sky are already places you can never reach. Not because they are hidden, and not because they are too faint, but because the space between us and them is growing faster than anything could ever cross it. The light has arrived. The door has closed. And almost nothing about the sky reveals that this has happened. To understand why, it helps to notice that there are two different questions hiding inside the simple act of looking up. The first question is how far we can see. The second is how far we can reach. In ordinary life, these two questions have the same answer, and we never think to separate them. If you can see a distant hill, you can walk to it. If you can see a light across a valley, you could, given time and effort, arrive at it. Seeing and reaching travel together, and the eye becomes a promise that the feet can follow. The universe does not honor that promise. On the largest scales, seeing and reaching come apart completely, and the gap between them turns out to be almost the whole sky. There are galaxies whose light falls into our telescopes every night that no spacecraft, no signal, and no beam of light could ever arrive at, even if it set out this very moment and traveled for the rest of time. The image is real. The galaxy is real. But the connection between us runs only one way, and only out of the past. This is the fact at the center of tonight's slow exploration, and it is worth stating plainly before we soften into it. The universe we can see is far larger than the universe we can ever touch. We can look out across a distance so great it strains every attempt to picture it, and yet the region we could still send a message to is only a small island within that view. Everything else, the overwhelming majority of what our instruments record, is already, in the deepest sense, beyond us. It is a strange thing to sit with, and there is a faint, unsettling weight to it at first, the sense of a separation already complete before we ever noticed it beginning. But the weight lifts once the picture becomes clear, because nothing about this separation is violent. No galaxy is torn away. No light is snuffed out. The distances simply grow, gently and evenly, the way they always have, until at some point they have grown beyond any crossing. The unreachable universe is not lost in any painful sense. It is only far and growing farther, in the quietest way imaginable. The reason seeing and reaching split apart is that the distance to a faraway galaxy is not a fixed number. It is a growing one. The space between us and a distant galaxy is not like the space between two towns, a settled measure you could cross at a steady pace. It is expanding. New distance is, in effect, appearing between us and everything far away, all the time, in every direction. And for galaxies far enough off, that new distance appears faster than light could ever close the gap. Seeing a galaxy, then, tells you something narrow and specific. It tells you that light once left that galaxy, and that after an enormous span of travel, some of that light has now arrived at your eye or your instrument. It does not tell you that the galaxy is still within reach. It does not even tell you where the galaxy is now, or whether a message sent back toward it could ever complete the journey. The light is a record of a departure, nothing more. It is a letter that arrived. It is not an address you can answer. For the nearest galaxies, this distinction hardly matters, because they are close enough that seeing and reaching still roughly agree. But for the distant ones, and the distant ones are almost all of them, the distinction is everything. When we look at a galaxy billions of light years away, we are seeing light that left it billions of years ago, when the universe was younger and the space between us was smaller. That ancient light has spent all the time since crossing the slowly widening gulf to reach us. And in many cases, the galaxy that sent it has since been carried so far, so fast, that no reply could ever follow the light back. There is a gentle way to hold this. Imagine a letter that arrives from a friend who has since moved somewhere you can never follow, somewhere no road leads and no message travels. The letter is genuine. The handwriting is real. The friendship it records truly happened. But any reply you write will never be delivered, because the place it came from is no longer a place you can reach. The light from the distant galaxies is exactly this kind of letter. It shows us that the galaxy was there, that it shone, that its light set out toward us long ago. It carries no promise that we could ever arrive. Once you see the universe this way, the night sky changes character, quietly and permanently. The stars scattered overhead belong to our own galaxy, and they are near and they are ours. But the faint smudges of light beyond them, the other galaxies, the deep field of distant worlds that telescopes reveal when they stare long enough into the dark, most of those are not our future territory. They are not waiting for us. They are an immense gallery of places we may admire for as long as we like, and never visit, and never touch, and never reach. And the light that shows them to us is the only contact we will ever have. That is the shape of what lies ahead tonight. We will move slowly through the reasons behind this quiet fact, taking each piece in turn and letting it settle before moving on. We will look first at how far the light has actually carried, and how the universe we can see came to be so astonishingly large. We will look at why space expands, and why that expansion means distant galaxies drift away from us faster the farther off they are. We will find the strange, calm boundary where the drifting becomes faster than light itself, and then the deeper boundary beyond which reach ends forever. We will put a number to it, a single, quiet figure that captures how much of the visible universe is already out of contact, and it is a larger number than almost anyone expects. We will look at what it means to watch a place you can never arrive at, and at how a galaxy actually leaves, which is not with any sudden vanishing, but with a slow and soundless fading. We will find the small part of the universe that stays with us no matter what, the bound island we belong to, and we will follow the story all the way into the deep future, to a sky that has grown quiet and solitary, in a way our own sky never will be. None of it needs to trouble you. This is not a story of danger or ending in any sense that touches a living thing. Everything described tonight unfolds across spans of time so enormous that no human life, no civilization, no world, with its whole long history of seasons and tides, ever feels the smallest part of it. The universe is not closing in around us. It is only slowly, evenly opening outward until the far parts of it drift past the point of any crossing. And there is, in the end, a deep and unexpected peace in that, in learning how much of the cosmos was never ours to hold, and in letting it be far, and letting it be beautiful, and letting it be enough, simply to see. So let the far lights be far, for now. Let the sky be larger than any reach, and let that largeness feel not like a loss, but like a kind of spaciousness, a room with no walls, a view that asks nothing of you in return. We are only here to look and to understand, and to grow slow and quiet in the understanding. The distances will take care of themselves. They always have. And the small, bright island that is ours will still be here when the looking is done. To understand how much of the universe lies beyond our reach, it helps first to understand how much of it we can see, because the seeing is where the whole story begins. And the size of the visible universe comes from a single fact so familiar that we forget how strange it is. Light travels fast, but it does not travel instantly. It takes time to cross space, and that simple delay shapes everything we can ever observe. Light moves at a fixed and enormous speed, quick enough to circle a small world many times in a single second. But the distances between the stars are so great that even this speed becomes slow. Light from the nearest star beyond our own takes years to arrive. Light from the far side of our own galaxy takes tens of thousands of years. And light from other galaxies takes millions or billions of years to complete its journey. Whenever we look out into space, we are also looking back into time, seeing not how things are, but how they were when their light departed. This means that the farther out we look, the further back we see. Look at a galaxy that is 1 billion light-years away, and you see it as it was 1 billion years ago. Look further, and you see further into the past. And there is a limit to how far back this can go, because the universe has a finite age. It has not existed forever. There was a beginning, a moment from which all the time since has unfolded, and light has only had the span since then to travel toward us. That finite age sets a boundary on what we can see. There is a maximum distance from which light could possibly have reached us, simply because beyond it, light would have needed more time than the universe has had. This boundary is a sphere centered on us, and everything inside it is, in principle, observable. Everything beyond it is not, because its light is still in transit and has not yet arrived. Astronomers call this sphere the particle horizon, or more simply, the edge of the observable universe. Now here is where the picture grows larger than intuition expects. You might think the edge of the observable universe would sit at a distance equal to the age of the universe, multiplied by the speed of light, a little under 14 billion light-years, since that is roughly how long light has had to travel. But the true edge is much farther than that, and the reason is that the universe has been expanding the entire time the light was on its way. Consider a galaxy whose light has been traveling toward us for most of the age of the cosmos. When that light first set out, the galaxy was relatively close. But over the billions of years, the light spent crossing the gap, space itself stretched, and the galaxy was carried steadily farther away. By the time the light finally arrives, the galaxy that emitted it is no longer where it was. It is now much more distant than the simple travel time would suggest. The light took a certain span to reach us, but the source has since drifted far beyond where it stood when the light began. When astronomers account for all this stretching, the edge of the observable universe turns out to lie at a present distance of roughly 46 billion light-years in every direction. The observable universe is a sphere about 46 billion light-years in radius and something like 93 billion light-years across. That is the extent of everything whose light has had time to reach us. It is a number almost impossible to hold in the mind, a distance so large that the fastest thing in existence would need 46 billion years to cross even its radius, if such a crossing were possible at all. The oldest light within this sphere is older than any star. It is a faint, even glow that fills the whole sky in every direction, left over from a time when the universe was young and hot and had not yet formed a single galaxy. This ancient light has been traveling for very nearly the entire age of the cosmos, and it marks, in a sense, the farthest back we can ever see. Beyond it lies a curtain we cannot look past, not because there is nothing there, but because the universe was not yet transparent to light when that glow was released. Within this boundless observable sphere, the universe is filled with galaxies, and their number is staggering. The best estimates place the count at around 2 trillion galaxies inside the observable universe. 2 trillion islands of stars, each holding many billions of suns, scattered through the enormous volume of everything we can see. When a great telescope stares at a single small patch of apparently empty sky for long enough, it finds that patch crowded with faint galaxies, thousands of them, in a piece of the sky no larger than a grain of sand held at arm's length. Multiply that across the whole sphere of the sky, and the total climbs into the trillions. It is worth pausing on that number, because it is the number that gives tonight's fact its weight. 2 trillion galaxies are, in some meaningful sense, visible to us. They have been imaged, mapped, counted, and catalogued. They appear in the deep fields of our observatories as points and smudges of ancient light. And the natural assumption, looking at such a catalogue, is that this is our universe, the great territory to which we belong, the full expanse of everything that is, in principle, ours. But that assumption is where seeing and reaching quietly part ways. Visibility is not the same as belonging. A galaxy recorded in a deep image is a galaxy whose light has reached us, and nothing more. It is not necessarily a place we could ever go, or even send the faintest signal toward. As we will find, almost none of those 2 trillion galaxies are within reach. The catalogue of the visible universe is, for the most part, a catalogue of the unreachable, a sprawling record of places we can study and admire across the gulf of time, but never touch. One more thing must be said clearly, because it matters for everything that follows. The observable universe is not the whole universe. It is only the part whose light has managed to reach us in the time available. Space almost certainly continues far beyond the edge of what we can see, perhaps enormously far, perhaps without any end at all. There is no reason to think the universe stops at the boundary of our observation. That boundary is not a wall or an edge of anything real. It is simply the limit of our sight, a horizon set by the speed of light and the age of the cosmos, and it would sit in a different place for an observer in a distant galaxy, centered on them instead of on us. It is worth pausing, too, on the sheer depth of time folded into that oldest light, because it is the deepest seeing of all. That faint even glow filling the sky set out when the universe was only a few 100,000 years old, long before the first stars, from a time when all of space was a warm and featureless fog just beginning to clear. It has been traveling ever since, across the entire history of the cosmos, stretched and cooled by the expansion, until it arrives as the faintest whisper of warmth in the dark. When we detect it, we are seeing very nearly to the beginning, to the edge of the time when light could first travel freely at all. There is no seeing farther than this, not because space ends there, but because before it the universe was not yet clear enough for light to cross. And the crowding of the deep field is worth holding as well, because it is what makes 2 trillion an honest number rather than an abstraction. Point the most patient instrument at a patch of sky that looks utterly empty, a scrap of dark no larger than a grain of sand held at arm's length, and let it gather light for a long while, and that empty scrap fills with galaxies, thousands of them, faint and small and ancient, layered back through time. Every direction is like this. There is no truly empty patch of sky, only patches too faint for a quick glance to resolve. The whole celestial sphere is paved, edge to edge, with distant galaxies, and the mind can only gesture at what that fullness means. So we begin with an immensity. 46 billion light-years of visible space in every direction. 2 trillion galaxies of ancient light. A sphere so large that the mind can only gesture at it. And yet, as great as this seeing is, the reaching is far, far smaller. To understand why, we turn next to the reason the distances grow at all, to the slow, silent stretching of space itself, which is the engine behind the entire quiet separation we are here to trace. The whole reason the reachable universe is smaller than the visible one comes down to a single idea, and it is one of the most quietly powerful ideas in all of science. The universe is expanding. But the word expanding is easy to misread, and almost everyone pictures it wrongly at first. So it is worth taking slow and careful, because once it is clear, the rest of tonight follows naturally from it. When we say the universe is expanding, the mind reaches immediately for a familiar image. It pictures galaxies flying outward through space, like fragments hurled from an explosion, racing away from some central point where the blast began. This picture is vivid, and it is wrong. The galaxies are not flying outward through space. There is no central point they are fleeing. Nothing was thrown. The expansion of the universe is something stranger and gentler than an explosion, and understanding the difference is the key to everything. What is actually expanding is space itself. The distances between galaxies grow, not because the galaxies are traveling through space towards some destination, but because new space is, in effect, appearing between them. The galaxies are very nearly still. It is the space that stretches, carrying them apart the way markings on a stretching sheet drift away from one another while barely moving across the sheet at all. The galaxies ride on the expansion. They do not cause it, and they are not racing through anything. A well-worn picture helps here, and it is worth sitting with because it captures the idea so cleanly. Imagine a loaf of raisin bread sitting in a warm oven, slowly rising. The raisins are galaxies, and the dough between them is space. As the dough rises and expands, every raisin drifts away from every other raisin. Pick any raisin, and from its point of view, all the others are receding in every direction. Yet no raisin is moving through the dough. Each one stays fixed in its own patch of dough, while the dough itself swells, and the swelling carries them apart. There is something important hidden in that picture. No raisin is at the center. From the point of view of any raisin, it seems to sit still, while all the others move away, and every other raisin sees exactly the same thing about itself. There is no special raisin, no origin point, no place where the rising began. The expansion looks the same from everywhere. This is exactly how the universe behaves. From our galaxy, every distant galaxy appears to recede, and we appear to sit still at the center. But an observer in any of those distant galaxies would see the same thing, with themselves at the apparent center and us among the receding crowd. There is no true center to find. The expansion belongs to space everywhere, all at once. Now comes the detail that matters most, the one small feature of the raisin bread that unlocks the entire subject. Look again at the rising loaf, and pick 2 raisins that sit close together, and 2 others that sit far apart. As the dough expands, the 2 nearby raisins drift apart slowly, because there is only a little dough between them to swell. But the 2 distant raisins drift apart quickly, because there is far more dough between them, and all of it is expanding at once. The more space lies between 2 points, the more of it there is to stretch, and so the faster those 2 points move apart. This is the crucial rule, and it is worth stating on its own, because everything else tonight rests upon it. The farther away a galaxy is, the faster it recedes from us. A galaxy twice as distant recedes twice as fast. A galaxy 10 times as distant recedes 10 times as fast. The speed of recession grows in direct proportion to the distance, without limit, on and on, into the deep field of far galaxies. Nearby galaxies drift away gently. Distant galaxies rush away. And the most distant galaxies of all recede at speeds that begin to strain the imagination. It follows that somewhere out in that deep field, the recession must become very fast indeed. If a galaxy twice as far recedes twice as fast, and the rule holds all the way out, then at some great distance, the recession speed must climb to match, and then exceed the speed of light itself. There is nothing to stop it. The proportion simply keeps going. And that is the doorway through which, seeing and reaching part company, the distance at which galaxies drift away faster than light can travel toward them. We will step through that doorway shortly. It is worth dwelling for a moment on how calm all of this is, because the language of speed and rushing can make it sound violent, and it is not. The expansion is not a wind or a force tearing the galaxies apart. Within any single galaxy, nothing stretches at all. The stars are held together by their own gravity, orbiting quietly, unaffected. Even small groups of galaxies, bound tightly enough by gravity, hold together against the expansion and do not drift apart. The stretching only wins out across the enormous, nearly empty distances between the great clusters of galaxies where gravity is too thin to resist it. There, and only there, does space quietly carry everything apart. So the expansion is not a catastrophe unfolding around us. It is a slow, smooth, universal stretching, the same in every direction, the same from every galaxy, unfelt by anything small enough to be held together. A person, a world, a star, a whole galaxy, none of these grow. Only the immense gaps between the galaxies widen, and they widen gently, on timescales so long that nothing alive could ever notice the change within a lifetime, or a civilization, or the entire history of a living world. And yet, gentle as it is, this stretching is relentless, and it never stops. Every day, the distant galaxies are a little farther than they were. Every age, the gaps have widened. The expansion has been underway since the beginning, and it continues now, silently, in every empty stretch of space between us and everything far away. It is the quietest process imaginable, and it is remaking the reachable universe with every passing moment, drawing the far galaxies always a little further out of contact. This, then, is the engine behind tonight's fact. Not an explosion, not a wind, not a force, but the simple, even stretching of space, growing the distances between the galaxies in proportion to how large those distances already are. It is why the far galaxies recede faster than the near ones. It is why, at some great remove, the recession outpaces light. And it is why the universe we can reach is only a small island within the universe we can see. To find the edge of that island, we follow the rule to its natural conclusion, out to the distance where the galaxies slip away faster than any light could ever follow. If the recession of galaxies grows in proportion to their distance, and the rule holds without limit, then there must be a distance at which galaxies recede from us at exactly the speed of light. Nearer than that, they recede more slowly than light. Farther than that, they recede faster. This special distance has a name. It is called the Hubble radius, and it sits at roughly 14 billion light-years from us. Beyond it, galaxies are drifting away faster than light itself can travel. At first hearing, that sentence sounds impossible. We are often told that nothing can move faster than light, that this is one of the firmest rules in all of physics. And it is a firm rule. But it applies to motion through space, and the recession of the distant galaxies is not motion through space. It is the stretching of space itself, and the stretching of space obeys no such limit. This is the single most important distinction in the whole subject, and it is worth taking slowly, because it dissolves what seems at first like a contradiction. Think again of the galaxies as very nearly still, each one resting quietly in its own patch of space. None of them is racing anywhere. If you could stand beside a distant galaxy, you would find it drifting slowly among its neighbors, moving no faster than the galaxies near us move among theirs. It is not hurtling through the cosmos. It is calm and local and slow. What makes it recede from us so quickly is not its own speed, but the enormous amount of space lying between us, all of it expanding at once. The galaxy is still. The space is what moves. And the expansion of space carries no speed limit, because it is not a thing traveling from one place to another. The rule that forbids faster than light travel is a rule about objects and signals moving through space, chasing one another across it. It says nothing about how quickly space itself can grow. Space can stretch as fast as it likes between two distant points, because the stretching does not carry any object or any message from one place to the other. It simply widens the gap. So a galaxy can recede from us faster than light, while never for a single moment moving quickly at all. This is why the boundary at 14 billion light-years is such a quiet threshold rather than a dramatic one. Nothing happens there. There is no barrier, no shimmer, no place where the sky changes. A galaxy sitting just beyond the Hubble radius looks no different from one sitting just inside it. The threshold is invisible, marked only by the arithmetic of expansion, the distance at which the widening of space finally matches, and then outpaces the speed of light. Now, the consequence for reaching becomes clear, and this is the heart of it. Imagine we wished to send a signal, a beam of light, the fastest messenger there is toward a galaxy beyond the Hubble radius. The light sets out at its full speed, crossing space as quickly as anything can. But the space between our light beam and that galaxy is expanding faster than the light can cross it. Every moment, the gap ahead of the beam grows by more than the beam advances. The light travels and travels, doing everything it can, and still the distance to the galaxy increases. The signal never arrives. It cannot arrive. The road ahead lengthens faster than the traveler can walk it. A gentle picture makes this vivid. Imagine a swimmer setting out across a wide river, trying to reach a point on the far bank. The swimmer is strong and swims at a steady pace. But the river flows against them faster than they can swim. With every stroke, the swimmer moves forward through the water, and yet the water itself carries them backward faster than they advance. so the far bank grows steadily more distant. The swimmer never tires and never stops, and still the far shore recedes. This is precisely the situation of a beam of light aimed at a galaxy beyond the Hubble radius. The light does its utmost, and the river of expanding space carries the goal away faster than the light can close on it. There is a subtle and beautiful complication here, and it is worth including because it is exactly where seeing and reaching reveal themselves as different things. It turns out that we can still see many galaxies that are currently receding faster than light. This seems at first to contradict everything just said, but the resolution is elegant. The light we see from those galaxies was emitted long ago, in the distant past, when the galaxies were much closer to us and the space between us was far smaller. Back then, the expansion across that shorter distance was slower than light, and so the light was able to make headway and begin its long journey toward us. Over billions of years, that ancient light has slowly, painstakingly crossed the widening gulf, losing ground at first and gaining it later, until at last it reached us. So, the light we see from a faraway galaxy is old light, sent when the reaching was still possible. It records a moment when the galaxy was near enough, and the space between us small enough that a signal could still cross. The galaxy has since been carried far beyond that threshold. We see its past, when it was reachable. We cannot touch its present, now that it is not. The very light that lets us see it is proof that reaching was once possible, and the galaxy's present distance is proof that it no longer is. This is the precise sense in which seeing and reaching have come apart. Seeing looks backward, into the past, at light already sent and already arrived. Reaching looks forward, into the future, at whether a new signal could ever complete the journey. For the near galaxies, past and future agree, and both seeing and reaching are possible. For the far galaxies, they diverge. We can see them, because their old light made it across. We can never reach them, because no new light ever could. The sky is full of visible galaxies that are, in the forward direction, entirely beyond us. There is a detail in that ancient light worth lingering on, because it is one of the strangest and most beautiful in all of cosmology. A beam of light from a distant galaxy, one that is receding faster than light when it sets out, does not simply sail toward us. At first, it actually loses ground. The space between it and us is expanding so quickly that for a long while, the light is carried backward, growing more distant from us, even as it races in our direction with all its speed. It is the swimmer at the moment the current is strongest, being swept downstream despite every stroke. And yet the light does not give up, because it cannot. It simply keeps traveling at its fixed speed through the space around it. What saves such a beam is that the expansion, across the particular distance it must cross, eases just enough over time for the light to begin making headway. Slowly, after ages of losing ground, the beam reaches a turning point, and thereafter it gains on us, creeping closer across the still widening gulf until, at last, after billions of years, it arrives. The oldest light we see has often traveled exactly this tortured path, carried away first, then clawing back, a journey of losing and then winning that spans nearly the whole age of the universe. That we see such galaxies at all is the residue of a crossing that very nearly failed, and only the gentleness of the early expansion allowed to succeed. And so the 14 billion light-year threshold of the Hubble radius begins to explain the whole quiet fact. Beyond it, galaxies recede faster than light. Beyond it, no signal we send can ever arrive. Beyond it, seeing continues, but reaching ends. Yet even this is not quite the final boundary, because the Hubble radius shifts over time, and some galaxies just beyond it can, under certain conditions, still be reached by light sent long enough ago. To find the true and permanent edge of reach the line past which contact ends forever, no matter when the signal is sent, we need one more idea. We need to look at the fact that the expansion is not merely continuing, but speeding up. And that is where the real horizon lies. The expansion of the universe would be a much simpler thing if it were merely steady. For a long while, that is what most people expected, that the expansion, set in motion at the beginning, would gradually slow over time, its pace easing as the gravity of all the matter in the cosmos gently pulled against it. A universe like that would be forgiving. Light sent toward a distant galaxy might struggle at first, but as the expansion slowed, the light could eventually catch up, and given enough time, nearly everything might be reached. But that is not the universe we live in. Our universe is not slowing down. Its expansion is speeding up. The distant galaxies are not merely receding, they are receding faster and faster as the ages pass. The rate at which space stretches is increasing, and every galaxy beyond our immediate neighborhood is accelerating away from us, drifting outward more quickly with each passing epoch. This is one of the most profound discoveries about the cosmos, and it changes the entire story of reach, turning a soft and temporary boundary into a hard and permanent one. The cause of this acceleration is not fully understood, and it goes by a name that is really a placeholder for a mystery. It is called dark energy. It appears to be a property of empty space itself, a faint, steady pressure woven into the vacuum, present everywhere, pushing the expansion ever onward and ever faster. The more space there is, the more of this energy there is, and so the expansion feeds upon itself, growing as the universe grows. Astronomers can measure its effects with care and confidence, tracking the accelerating drift of the distant galaxies, even as its deeper nature remains one of the great open questions. For tonight, what matters is not what dark energy is, but what it does. It makes the expansion accelerate. And acceleration is what closes the door. In a universe whose expansion is accelerating, there exists a true and permanent boundary, and it is different from the Hubble radius we met before. It is called the cosmic event horizon. It sits at a present distance of roughly 16 to 18 billion light-years from us. And it marks the absolute limit of everything we could ever reach. A signal we send out today, a beam of light, a probe, a message of any kind, can only ever arrive at galaxies that lie within this horizon. Anything beyond it is receding and accelerating, so relentlessly that no signal will ever catch up to it. Not in a billion years, not in a trillion, not in any span of time, however long. The cosmic event horizon is the edge of the reachable universe, and it is a boundary that time cannot undo. The difference between this horizon and the earlier one is worth making plain, because it is the difference between a delay and a finality. The Hubble radius is the distance at which galaxies currently recede at the speed of light, but it shifts over time, and light can sometimes cross it under the right conditions. The event horizon is stronger. It accounts for the acceleration, for the fact that the expansion will keep speeding up forever. It is the line drawn not by where the galaxies are now, but by where the relentless acceleration will forever keep them. A galaxy beyond the event horizon is not merely hard to reach. It is unreachable in the fullest sense, sealed away by the forward march of an expansion that only ever quickens. This is the quiet, emotional center of the whole subject, and it deserves to be held gently, without any weight of dread. The cosmic event horizon is a soft, invisible surface, hanging at the same distance in every direction, surrounding us on all sides. On our side of it, contact with the universe is still possible. On the far side, the door has already closed. And the strangest thing about this door is that its closing is utterly silent. Nothing marks it. No galaxy flickers as it passes beyond. No sign appears in the sky. The horizon is not a place, and crossing it is not an event. It is simply the line past which cause and effect can no longer travel between 2 points in space. There is a parallel here that can help the mind grasp the shape of it, and it must be drawn carefully, without any of the fear the comparison sometimes carries. A black hole, too, has an event horizon, a surface around it past which nothing, not even light, can send a signal back out. Anything that crosses inward is sealed away from the outside, unable to return or report. The cosmic event horizon is the same idea, turned gently inside out. A black hole's horizon surrounds a region you cannot escape from. The cosmic horizon surrounds the region you cannot reach out to. One holds things in, the other holds things off. But in both cases, the horizon is not a wall, not a barrier, not a thing at all. It is only the boundary beyond which two places can never again influence one another. And in both cases, the horizon is defined by light. It is the line past which the fastest possible messenger, moving at its full and constant speed, can still just barely make the journey, and beyond which, even it falls forever short. For the black hole, the light that tries to leave is pulled back by gravity faster than it can climb away. For the cosmos, the light that tries to arrive is carried back by expanding space faster than it can advance. Different causes, the same quiet result: a surface, hanging in the dark, past which no signal ever crosses, and beyond which two regions of the universe are, for all of time, entirely separate. It is worth resting a moment in how calm this boundary truly is, because everything about the word horizon can suggest an edge or a fall, and there is neither here. Standing within the cosmic event horizon feels like nothing at all. The sky looks whole and continuous in every direction. The galaxies beyond the horizon are still perfectly visible, their old light still arriving, showing us the moment when they were near enough to reach. There is no gap in the view, no dark ring, no missing piece. The horizon is felt only in the forward direction, in the impossibility of ever sending anything new toward the places beyond it. It is a boundary of the future, not of sight. We see across it freely. We simply cannot reach across it ever again. It is worth understanding why acceleration, in particular, is what makes the horizon permanent, because it is the hinge on which the whole future turns. In a universe that merely expanded at a steady pace or slowed over time, the horizon of reach would keep growing, and patient light could eventually arrive almost anywhere. Given enough ages, nearly everything would fall within reach. But an accelerating expansion behaves differently. It settles, over the long run, into a steady exponential growth in which every region of space doubles its size again and again at a constant rhythm. And a doubling that never stops will always outrun a traveler moving at a fixed speed, no matter how long that traveler journeys. That is the deep reason the door stays shut. Against a steady expansion, light is a swimmer who can eventually reach any shore if the river is patient enough. Against an accelerating one, the far shores are being pushed away faster and faster forever, and no amount of swimming will ever close the gap once it has grown too wide. The acceleration turns a temporary lag into a permanent separation. It is not that the light is too slow. It is that the distance itself is growing in a way that no finite speed can ever catch. This is why the cosmic event horizon is a true and final boundary, and not merely a line that patience could someday cross. So now the two great distances of tonight stand fully revealed, and they can be placed side by side. We can see out to roughly 46 billion light-years, the edge of the observable universe, the reach of the oldest light. But we can only ever touch out to roughly 16 to 18 billion light-years, the cosmic event horizon, the true edge of contact. Between those two figures lies an enormous shell of space, filled with galaxies, every one of them visible, and every one of them beyond reach. And because that shell is by far the larger volume, the majority of the visible universe already lies within it. Just how much, and just how quiet that number turns out to be, is where we turn next. Now we can put a number to the whole quiet fact, and it is the number that gives tonight its shape. We have two distances. We can see out to about 46 billion light-years. We can reach out to only about 16 to 18 billion light-years. Everything that lies in the space between those two figures is visible but permanently beyond contact. And when you compare the sizes of those two regions, the result is striking in its stillness. The volume of a sphere grows very quickly with its radius. Doubling the radius does not double the volume, it multiplies it many times over. So the observable universe, reaching out to 46 billion light-years, encloses a volume vastly larger than the reachable universe, which extends to only a third of that distance. The reachable region, though enormous in its own right, is only a small kernel at the very center of the far greater sphere of everything we can see. Almost all of the visible volume lies outside the horizon of reach. Translate that into galaxies, and the number becomes something you can hold. Of the roughly 2 trillion galaxies within the observable universe, only a small fraction lie within the cosmic event horizon. Careful estimates place that reachable fraction at only a few percent, commonly around 3%, which means that something close to 97% of the galaxies we can currently see are already beyond any signal we could ever send. They are visible, catalogued, studied, and utterly out of reach. Let that figure settle, because it is easy to say and hard to feel. For every 100 galaxies that appear in the deepest images of the sky, roughly 97 are places we could never reach, even if we set out this very moment at the speed of light and traveled onward for the rest of eternity. Only about 3 in 100 remain within the horizon of contact. The overwhelming majority of the visible universe is, in the deepest and most permanent sense, already gone from us, not vanished, not destroyed, simply carried beyond the reach of any possible crossing. This is the fact that reframes the night sky. When we look out at the deep field of distant galaxies, we are not looking at a territory we might one day explore. We are not surveying our future domain. We are looking at an immense gallery of places that have already drifted past the edge of reach light, from destinations that no longer belong to the reachable world. The catalogue of the visible universe is, for the most part, a catalogue of the unreachable. The great majority of everything our instruments have ever recorded is a collection of far shores we may study across the water and never cross to. It is worth being precise about what beyond reach means here, because it is stronger than it first sounds. It does not mean merely that we lack the technology, or the speed, or the patience. It means that no conceivable signal, moving at the greatest speed the universe allows, could ever complete the journey, no matter how long it traveled. Even a beam of light, released now and aimed with perfect accuracy at a galaxy beyond the horizon, would fall forever short, the expanding space ahead of it always lengthening faster than the light could advance. The unreachability is not a limit of our means. It is a feature of the universe itself. And what remains within reach is a small and quiet neighborhood. Within the cosmic event horizon lie the galaxies close enough that their present distance still falls inside the boundary of contact, and closest of all, and most securely ours, is the small family of galaxies bound to us by gravity, the ones that will never drift away at all. Everything beyond that neighborhood, out to the far edge of sight, is receding into the unreachable. The reachable universe is not the great sphere of visible galaxies. It is the small, bright core at its center, surrounded by an immensity we can only ever watch. There is a particular kind of stillness that comes with this number, and it is worth naming so the video can rest in it rather than flinch from it. The first instinct, on hearing that 97% of the visible universe is beyond reach, is to feel a small ache, a sense of something enormous already lost. But the right register is gentler than loss. Picture standing on the near shore of a wide and quiet bay at dusk, looking across the water at the distant lights of a far coastline. The lights are beautiful. They are real. There are people and places behind them. And they are simply too far to cross to, tonight or ever. There is no tragedy in it. There is only distance, and the calm acceptance of distance, and the beauty of far lights that ask nothing of us but to be seen. The unreachable galaxies are like those far lights, multiplied beyond counting and scattered across the whole sky. Each one is a real place, an island of hundreds of billions of stars, some of them perhaps warmed by worlds of their own. And all of them, save the small handful near us, lie on the far side of a bay too wide to cross. We may look as long as we like. We may study their light, learn their shapes, trace their histories in the ancient glow they send us. But we will never arrive, and they will never know we watched. The separation is total, and it is calm, and there is a strange completeness in how absolute it is. It also helps to remember what this number is not. It is not a countdown, and it is not a threat. Nothing about the 97% presses upon us or endangers anything. The galaxies did not recede in anger, and they take nothing from us as they go. Our own galaxy is untouched. The stars overhead are as near and as bright as they ever were. The sun rises and sets on its familiar schedule, indifferent to the horizon of reach hanging far beyond it. The enormous unreachability of the cosmos changes nothing about the ground beneath us or the sky we actually live under. It is a fact about the far distances only, and the far distances have always been far. Perhaps the deepest thing to notice is that we were never in a position to reach those galaxies in the first place. There was no earlier age when the 97% were ours and we let them slip away. From the very beginning, the expansion of space set the terms, and the far galaxies were always destined to drift beyond contact, carried off by a stretching that began before any of us existed and will continue long after. We did not lose them. We never held them. They were far when the first eyes on any world looked up, and they will be far forever. The number simply names a separation that was written into the universe from the start. It is worth turning the number over once more, gently, to see how much of it we could ever have changed, because the answer is a quiet source of peace. Suppose we could travel at the very speed of light, the fastest anything is allowed to move. Suppose we set out this instant, in every direction at once, sparing no effort and never stopping. Even then, we would only ever arrive at the galaxies already within the horizon of reach, the same few percent. The other 97 would still recede beyond us, forever, no matter how perfectly we traveled or how long we endured. The limit is not one of ambition or engineering. It is woven into the geometry of the universe itself. And this is oddly freeing, once it settles. There is no effort we failed to make, no chance we squandered, no better path we might have taken to hold on to the far galaxies. They were beyond reach before the first living thing anywhere opened its eyes, and they will be beyond reach after the last star fades. Our not reaching them is not a defeat. It is simply the shape of things, as fixed and blameless as the roundness of a world or the brightness of the sun. We may let go of any sense that something was lost through fault or failure. Nothing was. The far galaxies were always going to be far, and that is all. And so the great figure of tonight, 97% unreachable, 3% within reach, is not a wound, but a description. It describes the shape of the cosmos honestly, a universe far larger than any single place within it, most of it visible and none of it required, a small bright island of reachable galaxies afloat in an ocean of far and beautiful light. To understand what it means to live inside that shape, we turn next to the strange experience at the heart of it all, what it is to see, night after night, a place that we can never, ever reach. There is something worth dwelling on in the simple act of seeing a galaxy we can never reach, because it is stranger and gentler than it first appears. Every galaxy we observe is shown to us not as it is, but as it was. The light that reaches us tonight left those galaxies long ago, and it has been traveling ever since, carrying an image of a moment that has long since passed. We never see a distant galaxy in its present. We see only its past, delivered across an enormous gulf of time. For the nearby galaxies, this delay is modest, a few million years, a small slice of cosmic history. But for the far galaxies, the ones that make up almost all of what we can see, the delay is immense. Their light set out billions of years ago, when the universe was young and those galaxies were newly formed. What we see is not the galaxy that exists now, but the galaxy as it was in its distant youth, preserved in light, like an old photograph that has been in transit for the whole of that time. The image is faithful to the moment it left. It says nothing about the moment we receive it. This means that when we look at the most distant galaxies, we are, in a real sense, watching ghosts. The light shows us a place that was there, that shone, that sent its glow toward us across the widening dark. But the galaxy that emitted it has continued to live and change through all the ages since, and for the boundless majority of them, the ones beyond the horizon of reach, has also been carried permanently out of contact. What we see is not the place itself, but the memory of the place, a still image of a shore that has long since drifted beyond any crossing. The light is genuine, and the galaxy is genuine, but the thread between us runs one way only, and only out of a past that can never be answered. It is worth sitting with how complete this one-directional connection is. We receive their light, but we can send nothing back. We witness their youth, but we cannot touch their age. We know they were there, but we cannot know what they have become, and we never will, because no signal we send will ever arrive to ask, and no signal from their present will ever reach us to tell. The relationship is entirely a relationship with the past. The galaxies speak to us across time in a language of ancient light, and we listen, and we can never reply, and they will never know they were heard. And yet there is a softness in this, once the first strangeness passes. The oldest light in our sky is a kind of company that asks nothing of us at all. It does not demand that we answer, or follow, or reach. It arrives quietly, having traveled for longer than the Earth has existed, and it simply shows us what was there. It offers the view freely, without any expectation. We are permitted, for as long as we care to look, to watch the deep past of the universe unfold across the sky, with no obligation to do anything but see. There is a rare and gentle grace in being given so much and asked for nothing in return. Consider what that light has crossed to reach us. It left its galaxy when the universe was a fraction of its present age, before the sun had formed, before the earth existed, before there was anything here to see it. It traveled through the widening dark for billions of years, through the long ages while galaxies turned and stars were born and died, while the space it crossed slowly stretched around it. It survived the whole of that journey, arriving at last, faint and reddened and old, to fall upon an instrument built by beings who did not exist when it set out. And it carries, folded within it, a true image of a place at the far edge of time. That such a thing reaches us at all is quietly astonishing. There is a way of seeing the night sky, then, that turns it into a kind of sprawling and silent archive. Every point of distant light is a message from a moment that will never come again, sent by a place we can never visit, preserved perfectly across an unimaginable span of time and distance. The sky is not a map of where things are. It is a record of where things were, layered by depth, the nearer galaxies showing us the more recent past, the farther ones showing us deeper and deeper into the history of the cosmos. To look up is to look back, and to look far is to look long ago. And the unreachability, rather than making this sadder, gives it a certain purity. Because we can never go to these places, our relationship with them can only ever be one of witness. We are not their explorers, and never will be. We are their audience. Their light performs for us across the dark, showing scenes from a past that is closed to us in every way, except this one, the way of seeing. It is a connection made entirely of light and time, with no possibility of contact. And perhaps that is why it feels so peaceful. There is nothing to reach for, nothing to strive after, nothing that could be lost by failing to arrive. There is only the light, and the watching, and the quiet. It changes, too, how we might feel about the far galaxies fading, when we come to that part of the story. For if our whole connection with them was always only a connection with their past, then their drifting beyond reach takes nothing from us that we ever truly had. We could never have gone to them. We could only ever have watched them. And watching, in its own way, remains for a long while yet. The old light keeps arriving, keeps showing us the deep past, keeps offering the view. What we have is the seeing, and the seeing was always all we had, and it is a great deal to have. There is a further gentleness in realizing that the galaxies never needed us to witness them, and never will. Their light streams outward in every direction, filling the whole sphere around each of them, whether or not any eye is there to catch it. The small portion that happens to fall upon us is an accident of geometry, a single thread among countless threads spreading through the dark. We are not their audience in any way they could know. We are simply one of the places their light happens to reach, and our seeing takes nothing from them and adds nothing to them. They shine as they shine, indifferent and complete, and we are fortunate merely to stand in the path of a little of it. That indifference, far from being cold, is part of what makes the watching so restful. Nothing is asked of us as we look. We are not needed. We are not responsible for the far galaxies, cannot help them, cannot reach them, cannot change anything about their long, slow drift into the dark. There is nothing to do but see, and even the seeing is optional, and the galaxies would carry on exactly the same whether we looked or turned away. To watch under those terms is to watch freely, with no duty and no stake, the way one watches, rain fall or firelight move, a thing complete in itself, offered to no one, and gently available to anyone who happens to look up. So the strange experience in every heart of tonight is this: to stand beneath a sky full of places we can never reach, and to find that the seeing itself is enough, that the ancient light asking nothing of us is a gift rather than a loss, that a one-way connection made of old light is still a real and lasting bond. The galaxies show us their youth, and we receive it, and the receiving is complete in itself. There is no need to arrive. There was never going to be an arrival. There is only the long, quiet looking, and the light that keeps on coming, older than the world, gentle as anything, across the widening dark. It is natural to imagine that when a galaxy passes beyond the horizon of reach, it must vanish, wink out, go dark, disappear from the sky in a single moment. But that is not how it happens. The departure of a galaxy is one of the gentlest processes in all of nature, a fading so gradual and so soft that at no single instant could you point and say, "There, now, it is gone." Galaxies do not leave with any suddenness. They leave the way a lamp leaves a long hallway, dimming and reddening as it is carried slowly into the dark. The reason lies in what expansion does to light. As space stretches, the light traveling through it stretches too. A wave of light crossing an expanding gulf is drawn out, its crests pulled farther apart, its wavelength lengthened. In the language of color, this means the light shifts toward the red end of the spectrum, a deepening redshift. The farther the light has traveled through expanding space, and the faster that space is receding, the more its light is stretched, and the redder and longer its waves become. For a galaxy drifting toward the horizon, this stretching grows without bound. Its light, which may have left as ordinary starlight, arrives shifted first toward the red, then beyond red, into the infrared, the warm, invisible glow below what the eye can see. As the galaxy recedes further, its light stretches further still, sliding into longer and longer wavelengths, down toward the radio, and then toward wavelengths so long that no instrument can register them at all. The galaxy does not go dark all at once. Its light simply lengthens and reddens and slips out of every window through which we might have caught it, one after another, until nothing detectable remains. At the same time, the galaxy dims. The stretching of its light spreads the energy of each wave thinner, and the expansion carries its photons farther apart, so that fewer and fewer arrive in any given moment. The galaxy grows fainter and fainter, its light thinning toward nothing, even as its color slides ever redward. It is a double, fading, a loss of brightness married to a loss of color, and both proceed together, smoothly, without any threshold or jolt, as the galaxy is carried gently outward. There is a further effect, subtle and beautiful, that shapes how the very end of the fading unfolds. As a galaxy approaches the cosmic event horizon, its light not only reddens and dims, but seems to arrive more and more slowly, as though time itself, seen across that widening gulf, was stretching along with the space. Any process in the galaxy, the turning of its stars, the slow pulse of its brightness, appears to us to unfold at an ever more languid pace, drawn out, decelerating. The galaxy seems to slow as it nears the horizon, its final light thinning toward an infinite redshift, rather than cutting off at any particular moment. This means that, strictly speaking, we never quite see a galaxy cross the horizon. From our vantage point, it approaches the boundary and slows, its light reddening and fading and arriving ever more sluggishly, drawing out its last appearance longer and longer, without ever reaching a definite final instant. The galaxy fades towards stillness, the way a sound fades towards silence, growing quieter and quieter, without a clear moment of ending. It does not disappear. It approaches disappearance forever, its last light stretched so far and dimmed so deeply that it simply falls below all possibility of being seen, gently and without any event to mark it. There is no flash then, and no sudden dark. A galaxy leaving the reachable universe is like a candle carried down a long corridor and around a distant corner, its glow softening and reddening, its light growing thin, its edges blurring into the dark, until at some point you realize you can no longer make it out, though you could not say exactly when it passed from sight. The leaving is all slope and no edge. It is the softest possible way for something so great to depart, and it is worth holding on to that softness because it is true to the physics and true to the tone at once. It is also worth remembering that from the galaxy's own point of view, nothing whatsoever is happening. There is no horizon in its sky, no boundary it crosses, no moment of severance. It drifts among its own neighbors, its stars turning quietly, its light streaming outward in every direction, as it always has. The horizon is entirely a feature of the relationship between that galaxy and us, born of the space expanding between. The galaxy does not fade for itself. It fades only for us, and even that fading is soundless and slow, and without any sign, on either side, that a separation is taking place. So, the picture of a departing galaxy is not one of loss in any violent sense, but of a long, slow softening into the dark. The light reddens through every color and past every color. The brightness thins toward nothing. The final image draws out and slows, approaching an ending it never quite reaches. And all of it unfolds across spans of time so immense that no observer could ever watch a single galaxy complete the process it takes, far longer than any life or any civilization or any world could last. What we would see, if we watched, is only the faintest imaginable dimming, imperceptible within any human span, a fading measured in the slow turning of cosmic ages. And this gentleness is a kind of mercy in the shape of the universe. The far galaxies do not blink out and leave a wound in the sky. They ease away, reddening and dimming so gradually that the sky remains, to any living eye, essentially full and whole and unchanged. The unreachability is real and permanent and enormous in scope, but it wears the softest possible face. Nothing is torn. Nothing snaps. The galaxies simply grow slowly, quieter and redder and fainter, drifting toward a silence they approach forever and never quite arrive at, in the most unhurried departure imaginable. There is a quiet symmetry worth noticing between this fading and the fading of light near a black hole, for the two are close cousins. An object falling toward a black hole's horizon appears, to a distant watcher, to slow and redden and dim in just this way, its light stretched toward longer and longer wavelengths, its motion drawing out, never quite reaching the moment of crossing. It hangs at the threshold, fading forever, approaching an ending it never completes. A galaxy nearing the cosmic horizon does the same, only turned inside out. It is not falling in, but drifting out, and yet the appearance to us is the same slow, reddening, decelerating fade toward a stillness that arrives only in the infinite distance of time. This tells us something gentle about the nature of horizons in general. They are not places where things end abruptly. They are places where endings stretch out forever, where the last moment is drawn so thin that it never quite occurs. A horizon does not sever, it softens indefinitely. Whether it is the edge of a black hole or the edge of the reachable cosmos, the light that approaches it does not snap off, but eases towards silence across an eternity, growing fainter and redder and slower, without ever reaching a final full stop. There is, in this, a kind of tenderness built into the deepest structure of the universe, a refusal, everywhere horizons appear, to let anything end all at once. There remains, though, one part of the universe that never fades at all, that never reddens or dims or slips toward the horizon, the small, bright family of galaxies bound to us by gravity, held close against all the stretching of space. While almost everything drifts away, this handful of galaxies stays and will always stay. And it is to that faithful island, the part of the cosmos that remains forever within reach, that we turn now. For all the talk of galaxies drifting beyond reach, it would be wrong to leave the impression that everything is leaving. It is not. There is a part of the universe that stays with us, faithfully and permanently, held close against all the stretching of space. It is small, compared to the great sphere of visible galaxies, but it is ours in the fullest sense, reachable now, reachable always, never to drift away. This is the family of galaxies bound to us by gravity, the neighborhood we belong to, called the local group. The local group is a small collection of galaxies, dozens of them in all, moving together through the expanding universe as a single bound company. It is dominated by two great spiral galaxies, our own Milky Way and the Andromeda Galaxy, with a scattering of smaller galaxies gathered around them, dwarf galaxies and satellites, drawn into the gravitational embrace of the two giants. The whole group spans something like 10 million light-years, a modest distance by cosmic standards, and within that span, gravity rules over expansion, holding everything together. This is the crucial point, and it is what makes the local group different from nearly everything else in the sky. On small enough scales, gravity is stronger than the expansion of space. Within a galaxy, gravity holds the stars in their orbits, and the galaxy does not expand. Within a bound group of galaxies, gravity holds the galaxies together, and the group does not fly apart. The stretching of space only wins out across the immense, nearly empty gulfs between the great clusters, where gravity has grown too thin to resist. Inside a gravitationally bound island like the local group, the expansion is overruled, and the members stay. So while the distant galaxies recede and redden and drift toward the horizon of reach, the members of the local group do no such thing. They are not being carried away from us. They move among themselves, drawn by mutual gravity, in a slow and intricate dance that has nothing to do with the cosmic expansion. The local group is decoupled from the stretching of the universe. It is an island that the tide cannot pull apart, floating whole and intact upon an ocean that carries everything else away. Because the local group is bound, it is the part of the universe that will always remain reachable to us, and we to it. Every galaxy in the group lies within any horizon of reach, and will stay there, because none of them is receding. A signal we send to Andromeda will arrive. A signal Andromeda might send to us would arrive as well. The bound family remains in permanent contact, its members able to reach one another across all the ages, no matter how fiercely the expansion accelerates in the empty spaces beyond. What is bound stays. What is bound can always be reached. And the two great galaxies of the group are not merely staying, they are drawing closer. The Milky Way and Andromeda are slowly falling toward each other, pulled together by their mutual gravity across the space between them. Over an immense span of time, they will approach and pass through one another and gradually merge, their stars intermingling, their two great spirals unwinding and combining into a single larger galaxy. This far future union is sometimes given a fond informal name, a blend of the two galaxies' names, a merged galaxy that will be, in a sense, the grand descendant of both. The bound island is not drifting apart. It is coming together. There is a quiet reassurance in this, set against the great emptying of the wider sky. While 97% of the visible universe drifts beyond reach, the part that is truly ours draws nearer and knits itself more tightly together. The galaxies we can actually reach are not leaving. They are converging, merging, consolidating into a single, enduring home. Everything within our gravitational island stays. Only the far things, the unbound things, the galaxies across the great gulfs, recede. Near home, the story is not one of separation at all, but of gathering. It is worth being clear about where the line falls between what stays and what goes, because it is closer than one might guess. Bound and staying are the Milky Way, Andromeda, and the several dozen smaller galaxies of the local group, a family spread across about 10 million light-years, held fast by shared gravity. Not bound and receding is essentially everything beyond that. The nearest large clusters of galaxies, the great sheets and walls of the cosmic structure, the countless galaxies of the deep field. Even the nearest big cluster of galaxies beyond our group is not bound to us, and is already drifting away with the expansion. The reachable, faithful part of the universe is genuinely small, a local neighborhood, and little more. But small does not mean poor. The local group holds a wealth almost beyond reckoning. Our own galaxy alone contains hundreds of billions of stars, and Andromeda holds as many or more. And among all those stars are countless worlds, and among those worlds, who can say what? The bound island is not a bare and lonely remnant. It is enormous and intricate home in its own right, full of light and structure and possibility, more than enough to occupy any mind or any civilization or any span of curiosity, for as long as there are minds to wonder and stars to shine upon. What stays is not a scrap. It is a kingdom. And in the far future, when the wider sky has emptied and the distant galaxies have faded past all seeing, this bound island will remain a single merged galaxy of intermingled stars, holding its light, keeping its structure, reachable in every part. It will be an isolated island then, surrounded by dark, but it will be whole, and it will be enough. The universe, having carried almost everything beyond reach, will leave us this: a home that never left, a family that only drew closer, a bright and enduring island held together by gravity against all the stretching of space. It is the part of the cosmos that was always and will always be ours. It is worth dwelling on why gravity wins here, while the expansion wins everywhere else, because the boundary between the two is what carves the reachable island out of the receding sky. The expansion of space is exceedingly gentle. Across the small distances within a bound group, its outward tendency is so faint that even the modest gravity of a few dozen galaxies overwhelms it completely, gathering them inward, holding them fast. It is only across the enormous, nearly empty gulfs between the great clusters, distances, tens and hundreds of times larger than the span of the local group, that gravity thins to nothing, and the expansion, unopposed, carries everything apart. The line between staying and leaving is drawn wherever gravity's pull finally fades below the steady push of expanding space. This means the reachable universe has a natural shape, and it is the shape of a gravitational island. Wherever matter has gathered densely enough to bind itself together, it stays, decoupled from the expansion, a permanent fixture of the reachable world. Wherever matter is spread too thin, it drifts. Our local group is one such island. There are countless others scattered through the cosmos, each bound within itself, each drifting away from all the rest. In the end, the universe sorts itself into these islands, each one holding together, each one receding from its neighbors, until every bound family floats alone. We simply happen to live aboard one of them, and it is a generous and enduring home. To understand how that far future isolation comes about, and why the reachable sky slowly empties even of the galaxies that lie within the horizon today, we need to notice one more thing about the horizon of reach, that it is not fixed, but shrinking, quietly drawing inward with every passing age. That slow contraction is where we turn next. There is a further turn to the story, and it is a quiet one, but it deepens everything that has come before. The reachable universe is not only small, it is shrinking. The horizon of reach is not a fixed boundary, drawn once and left in place. It is drawing slowly inward, age by age, as the expansion of the universe accelerates. The sphere of everything we could still send a signal to is contracting, gently and relentlessly, and more galaxies slip beyond it with every passing epoch. The reason follows directly from the acceleration. Because the expansion is speeding up, galaxies that recede slowly today will recede more quickly tomorrow, and more quickly still the age after that. A galaxy that sits just within the horizon of reach now, barely close enough that a signal could still arrive, will find its recession quickening as the ages pass, until at last it too crosses beyond the horizon and joins the unreachable. The boundary does not hold its ground. It falls back, steadily, surrendering galaxy after galaxy to the accelerating dark. This gives the whole subject a soft directionality, a sense of a slow closing. The universe we can reach was larger in the past than it is now, and it will be smaller in the future than it is today. Long ago, when the expansion was gentler, a signal could reach a greater share of the cosmos. In the far future, when the expansion has grown fierce, a signal will reach almost nothing beyond our own bound island. The window of contact with the wider universe is easing shut, not with any slam, but with the slow, sure motion of a door drifting closed across unimaginable spans of time. Imagine a message sent outward into the universe today, a beam of light, released now, aimed at the deep field of galaxies. That message would reach a certain sphere of destinations, the galaxies that lie within today's horizon of reach. Now imagine the same message sent instead 1 billion years from now. It would reach fewer galaxies, because in that 1 billion years the horizon will have contracted, and some of the galaxies reachable today will have drifted beyond it. Send the message later still, and it reaches fewer yet. Send it late enough, in the deep future, and it reaches almost nothing but the stars of our own merged home. The later the message, the smaller its possible audience. The reachable cosmos is always, quietly, growing smaller. There is a version of this that touches the imagination gently. If any wish were ever to be sent to the far galaxies, any signal, any greeting, any faint attempt at contact across the gulf, the time to send it is always now, and now grows a little poorer with every age. Not because of any urgency that presses on a human scale, but because the universe is slowly narrowing the set of places a signal can ever reach. Every epoch that passes, a few more distant galaxies pass forever beyond the possibility of being touched. The cosmos is closing its far rooms, one by one, softly, across the long ages. And yet it is essential to hold this contraction in its true proportion, because the language of closing doors can make it sound pressing, and it is the opposite of pressing. The shrinking of the reachable universe unfolds on timescales so boundless that they dwarf not only a human life, but the entire history of life on a world, the whole span of a civilization, the age of a planet. The horizon does not contract by any amount we could notice, or measure against anything we care about. It is a tide that moves across billions of years, imperceptible within any span that matters to anything alive. Nothing about it touches us, or presses on us, or asks anything of us. It is simply the slow, deep shape of the future, sketched faintly against a scale of time beyond all feeling. So the contraction changes nothing about the sky we actually live under. The galaxies visible tonight will be visible for ages beyond counting. The stars overhead will burn on their familiar schedules. The far galaxies will fade so slowly that no eye could ever catch them in the act. The shrinking of reach is real, and it is one of the deepest facts about the destiny of the universe. And it is also utterly gentle, utterly slow, and utterly harmless to anyone who happens to be looking up. It is a fact for the mind to hold, not a weight for the heart to carry. There is even a strange comfort in the slowness of it. The universe does not close its doors abruptly or cruelly or with any haste. It gives every age an enormous, unhurried span in which the sky remains rich and full. We happen to live in a time when the reachable universe is still large, when the far galaxies are still bright, when the horizon has not yet drawn deeply inward. That is a kind of fortune quietly given. And the narrowing that lies ahead is so gradual that it will leave the sky essentially untouched for spans of time that make the whole history of the Earth seem brief. There is no rush in it, and no threat, only the softest possible drift toward a smaller and quieter cosmos, ages upon ages away. Perhaps the gentlest way to hold the shrinking horizon is to see it not as a loss unfolding, but as a slow settling, the universe easing gradually towards stillness and separateness, the way a room grows quiet as the evening deepens. Each galaxy, drawn beyond reach, enters its own long quiet, no longer in contact with the others, resting in its own patch of expanding space. The cosmos is not being diminished. It is being distributed, spread out, each island of galaxies given its own solitude across the widening dark. The contraction of reach is, from another angle, simply the universe growing more and more spacious until every bound island floats alone. There is a soft irony in this contraction that is worth holding because it turns the usual picture of the expanding universe on its head. We are told, correctly, that the universe is growing, that space is swelling, that everything is spreading wider apart. And yet, from the point of view of what we can reach, the universe is not growing at all, it is shrinking. The very expansion that enlarges the cosmos is what draws in our horizon of contact, sealing off region after region. The bigger the universe becomes, the smaller our reachable share of it grows. Growth and diminishment are the same motion, seen from two sides. And so the reachable universe and the observable universe drift in opposite directions across the ages. The observable universe slowly enlarges as light from ever more distant regions finally arrives. The reachable universe slowly contracts as acceleration carries more galaxies past the horizon of contact. We will always, in time, be able to see a little more and always able to reach a little less. The gap between seeing and reaching, already sprawling tonight, only widens as the universe ages a growing gallery of visible, untouchable light and a shrinking island of everything we could still call within our grasp. And that final state, every bound island alone, the reachable sky, emptied of all but our own merged galaxy, is where the long story of expansion is ultimately heading. It is a future almost unimaginably distant and almost unimaginably quiet. And to follow the thread of tonight to its end, we must look toward it now. The deep future, the solitary sky, the island universe that everything is slowly, gently becoming. Follow the expansion far enough into the future, and a strange and beautiful picture slowly takes shape. As the ages pass and the horizon of reach draws inward, the distant galaxies redden and dim and fade, one after another, out of the reachable universe and then out of visibility entirely. The great deep field of 2 trillion galaxies does not stay full forever. It thins, slowly, across spans of time almost beyond naming, until at last the wider sky has emptied, and only our own bound island of stars remains in view. Picture an observer in that deep future, standing on some world within the merged descendant of the Milky Way and Andromeda, looking outward into the night. They would see the stars of their own galaxy, near and bright and familiar, wheeling overhead as stars always have. But beyond those stars, where we see the faint glow of countless other galaxies, they would see only darkness. The other galaxies would all have faded past the reach of any instrument, their light stretched and dimmed beyond any hope of capture. The sky beyond the home galaxy would be simply, entirely dark. This is the island universe, the state toward which everything is gently drifting. Each bound group of galaxies, carried apart from all the others by the accelerating expansion, ends as a solitary island of stars adrift in an ocean of dark. Our own island, the merged home galaxy, would float alone, its light intact, its stars turning, surrounded by an emptiness that reaches in every direction without a single other galaxy to break it. The universe, having carried almost everything beyond reach, would leave each island in its own quiet, self-contained, and alone. There is a profound solitude in that future, but it is worth being careful about how we hold it, because it is not a solitude of suffering. The island galaxy would be whole and full and rich, home to hundreds of billions of stars, more than enough to fill any sky with light. An observer there would not stand in a bare and empty cosmos. They would stand beneath a full and glittering canopy of their own galaxy's stars, wanting for nothing in the near sky. It is only the far sky, the sky beyond the home galaxy, that would be dark. And a being who had never known anything else might not feel that darkness as a loss at all. For such a being, the single galaxy would simply be the universe. There would be no reason to imagine anything beyond it. The stars of the home galaxy would seem to be all there is, floating in an eternal and unremarkable dark, and the idea of other galaxies, other islands, a wider cosmos once full of light, would seem like a strange and unfounded fancy. The far future sky offers no hint of the galaxies that once filled it. Their light is gone, stretched past all detection, and with it goes every clue that the universe was ever anything but a lone island in an endless night. It is a curious and quietly moving thought that the universe is slowly hiding its own extent, folding the evidence of its immensity away beyond the horizon. The richness we see tonight, the deep fields crowded with galaxies, the great structures of the cosmic web, the ancient light of the early universe, all of it is a feature of the era we happen to inhabit. It will not last. The universe is, ever so slowly, drawing a curtain across its own grandeur, and in the deep future, the curtain will be complete, and the grandeur will be invisible, and the cosmos will wear the plain and modest face of a single lonely galaxy in the dark. We live, then, in a rare and privileged moment, though it is a moment that lasts for a very long time by any human measure. We live in the age when the universe is still full of visible galaxies, when the whole cosmic story is still written plainly across the sky, when a being who looks up and looks far can read the history of everything in the light that arrives. This will not always be possible. Far future observers will not have this. The very completeness of what we can see tonight is a gift of our particular place in time, a window that is open now, and will, across the long ages, slowly and gently close. There is no fear in this future, and no catastrophe, only the deepest imaginable stillness. The island universe is not a disaster that befalls the cosmos. It is simply the long, slow settling of everything into separateness, each bright island easing into its own solitude, keeping its own light, no longer troubled by the others, no longer reaching or reached. It is peace on the largest possible scale, a universe grown so spacious that its parts no longer touch, each one resting alone and whole in its own great quiet, across a dark that asks nothing and threatens nothing and simply is. And perhaps that is the gentlest way to see the far future, not as an emptying, but as a spreading out into rest. The universe began close and hot and crowded, everything pressed together, and it has been easing apart ever since, growing more spacious, more separate, more quiet, age by age. The island universe is the far end of that easing, the state of maximum spaciousness, each home galaxy given all the room there could ever be. It is not the death of the cosmos. It is the cosmos come fully to rest, spread as wide as it can be spread, every island alone, beneath its own full canopy of stars. That future is unimaginably distant, and nothing about it presses on the present. Shiva, but it casts a soft light backward onto the sky we live under now, and it is worth carrying that light with us. It tells us that the crowded, luminous, galaxy-filled sky of our own era is precious and fleeting, a rare fullness in the long life of the cosmos. And it tells us, too, that even in the deepest solitude the universe can reach, there is no ending, only a home galaxy holding its light, alone and whole, in the quiet. Before we rest in that thought, though, there is one more strange consequence of the fading sky to follow the way the far future erases not just the galaxies, but the very story of how the universe began. The emptying of the far future sky carries a consequence stranger and deeper than the loss of the view alone. It hides not only the other galaxies, but the whole story of the universe itself. The clues that let us understand where the cosmos came from are written in the distant light, and when that light fades beyond reach, the clues fade with it. The far future universe becomes a place that conceals its own history, offering no evidence at all of the beginning that shaped it. Consider how we know what we know. Nearly everything we understand about the origin and growth of the universe comes from looking outward at distant things. The recession of the far galaxies is what reveals that space is expanding. The ancient light, left over from the young universe, filling the whole sky, is what tells us the cosmos was once hot and dense and small. The deep fields of galaxies at every distance let us watch the universe change through time, younger galaxies farther away, older ones nearby. Our entire grand picture of cosmic history is assembled from the light of distant things to read carefully across the gulf. Now imagine all of that light gone. In the far future, the distant galaxies have faded past detection, so there is nothing to reveal the expansion. The ancient light of the early universe has itself been stretched so far, dimmed so deeply, that it too slips below all possibility of being measured. The deep fields are empty. The only thing left to see is the home galaxy, its own stars turning quietly, offering no window onto anything beyond. Every external clue to the history of the cosmos has been carried past the horizon of reach, and with them goes the evidence of the beginning. A thoughtful observer in that far future, studying their solitary galaxy with great care and every instrument they could devise, would find no sign that the universe had ever expanded, no sign that it had ever been hot and dense, no sign that there had ever been other galaxies at all. they would see a single island of stars, apparently eternal, floating in a static and empty dark. And from that evidence, they would quite reasonably conclude that the universe was simply this one galaxy, unchanging, alone, with no beginning to speak of. The truth of the expanding cosmos, the 2 trillion galaxies, the ancient fire of the early universe, all of it would be not merely forgotten but genuinely undiscoverable, erased from the observable record. There is something quietly astonishing in that. The universe is, in effect, slowly deleting the evidence of its own origin. The story of the beginning is legible now, written across a sky still full of distant light, but it is being carried, piece by piece, beyond the reach of any future reader. The cosmos does not preserve its history in some permanent archive. It writes that history in light, and the light drifts away, and in the deep future the pages will be blank. What we can read tonight, a far future astronomer will not be able to read at all, because the words themselves will have receded past the edge of reach. This makes our own moment more remarkable still. We happen to live in the age when the universe's history is still readable, when the distant light still arrives, when the clues to the beginning are still scattered across the sky for anyone patient enough to gather them. We can look out and reconstruct the whole immense story, the expansion, the ancient fire, the growth of structure, the deep past of everything. That we can do this is a gift of timing, a consequence of living while the evidence is still here. Beings born too late will look at the same universe and see only a lonely galaxy in the dark, with no way to know what came before. It is worth resting on the gentleness of this, because it could sound like a warning, and it is not. Nothing is being taken from us. We have the full story, and we will keep it, for spans of time so long that they exceed all reckoning. The fading of the evidence is a fact about a future almost infinitely distant, and it touches nothing in the present. What it offers is not alarm, but perspective, a sense of how fortunate the seeing is, how rare and rich this era of the cosmos is, how much the sky is willing to tell us, while the telling is still possible. We are readers in a library whose farthest books are slowly being shelved beyond reach, and we happen to have arrived while nearly all of them can still be opened. And there is a soft consolation folded into even the far future's forgetting. The far future observer, seeing only their lone galaxy, would not feel any lack. Their universe would be complete to them, a full sky of stars, a home wanting for nothing. The story they could not read would not be a story they missed, because they would never know it was there to read. The forgetting is painless and total and quiet. The universe hides its history not cruelly, but gently, leaving each era with exactly the sky it has, and asking no one to mourn what they cannot see. So the far future erases the beginning as softly as it empties the sky, not with any violence, but with the same slow drift that carries everything beyond reach. The evidence recedes. The story quietly closes. And the cosmos settles into a state that remembers nothing of its own enormous past. Each island galaxy, alone with its stars, the great history of expansion and ancient light folded away past every horizon. It is the deepest solitude imaginable, a universe that has forgotten even itself, and it arrives so gradually that nothing ever feels it happen. Having followed the thread all the way to that distant, forgetful quiet, it is time now to gather up the pictures we have gathered along the way, and hold them softly together before we let the whole subject settle into rest. For there is a way to carry all of this that keeps the wonder and lets go of any weight, and it is worth finding before the night grows late. It helps, after following so long a thread, to gather the pictures we have collected and hold them together, softly, the way you might lay out a handful of stones brought back from a walk. Each one carries a piece of tonight's quiet fact, and set side by side, they make the whole thing easy to hold. There is no more reasoning to do. There is only the gentle settling of what we have already found. Begin with the two kinds of distance, the seeing and the reaching, which everyday life keeps joined and the universe pulls apart. We can see out to roughly 46 billion light-years, the edge of the observable universe, the reach of the oldest light. But we can only ever touch out to roughly 16 to 18 billion light-years, the cosmic event horizon, the true edge of contact. Between those two figures lies an enormous shell of galaxies, every one of them visible, every one of them beyond reach. The sky is far larger to the eye than it is to the hand. Hold, next, the picture of the rising loaf, the raisin bread swelling in its warm oven, every raisin drifting from every other as the dough between them grows. That is the universe, not galaxies flying through space from some central blast, but space itself gently stretching, carrying the galaxies apart. And the farther two raisins sit, the faster they part, because there is more dough between them to rise. So the far galaxies recede faster than the near ones, and the very farthest recede faster than light itself, not by moving quickly, but by resting still while an ocean of space swells between. Hold the picture of the swimmer in the river, striving toward the far bank, while the current carries them back faster than they can swim. That is a beam of light aimed at a galaxy beyond the horizon, doing its utmost, crossing space at its full unfaltering speed, and still falling forever short, because the road ahead lengthens faster than the light can walk it. The signal never arrives. It cannot arrive. And yet we can still see such galaxies by their old light, sent long ago when they were near enough that the crossing was still possible. We watch their past. We can never reach their present. Hold the number, the quiet figure at the center of everything. Of the 2 trillion galaxies we can see, only a few in 100 lie within reach. Something close to 97% of the visible universe is already beyond any signal we could ever send. And hold, beside it, the gentleness of that number, not a wound, not a loss, but a description of far lights on the shore of a widening bay, beautiful and real, and simply too far to cross to. We were never in a position to reach them. They were far when the first eyes on any world looked up, and they will be far forever. Hold the picture of the lamp carried down the long hallway, dimming and reddening as it goes, its glow thinning, its edges blurring, until you cannot say quite when it passed from sight. That is how a galaxy leaves, never with a sudden dark, always with a slow fading, its light stretched from visible to infrared, to radio and beyond, dimming and slowing, and reddening toward an ending. It approaches forever and never quite reaches. Nothing snaps. Nothing is torn. The departure is all slope and no edge, the softest leaving imaginable. Hold the island that stays, the bound family of the local group, the Milky Way and Andromeda, and their scattered smaller kin, held together by gravity against all the stretching of space. That island does not drift away. Its members draw closer, and the 2 great galaxies will one day merge into a single larger home. What is bound stays. What is bound can always be reached. And though it is small against the great sphere of visible galaxies, it holds hundreds of billions of stars and countless worlds, and more than enough light to fill any sky and any span of wonder. And hold, last, the far future, the solitary sky, the island universe toward which everything gently drifts. The distant galaxies fade past reach and then past seeing. The horizon draws slowly inward, and in the deep future, Each bound island floats alone beneath its own full canopy of stars, its far sky dark, its history folded away past every horizon. It is not a catastrophe. It is the cosmos come fully to rest, spread as wide as it can be spread, each home galaxy given all the room there could ever be. Solitude on the largest scale, arriving so gradually that nothing ever feels it happen. Set these pictures together, and the whole subject stands clear and surprisingly light. A universe far larger to the eye than to the hand. A gentle stretching that carries the far galaxies away. A boundary of reach that no signal ever crosses. A great majority of the visible cosmos already, quietly, beyond us. A soft fading rather than any sudden loss. A faithful island that stays and draws closer. And a distant, spacious, forgetful quiet at the end of all the ages. None of it presses. None of it threatens. It is simply the true shape of the cosmos, held softly in the mind. There is one thing left to do with all of these pictures, and it is the gentlest thing of all. It is to set them down, to let the far galaxies be far, and the near ones be near, and the whole immense machinery of expansion and horizon and fading light grow quiet and distant and harmless in the mind. We have followed the thread as far as it goes. Now we can let it rest, and let ourselves rest with it, and let the enormous calm distances of the universe carry us, at last, gently towards sleep. There is a first reaction to all of this that can feel, for a moment, like a small sadness. A universe full of places we can never go. Most of it already beyond reach. The far galaxies drifting further out of contact with every passing age, and a deep future in which each island of stars floats alone in the dark. Said quickly, it can sound like a story of loss, of a cosmos slipping through our fingers, of doors closing softly all around us across the sky. But there is another way to hold it, and it is truer, and it is the way worth carrying into sleep. The unreachable galaxies are not lost. They were never ours to lose. They are simply elsewhere, resting in their own patches of space, carrying their own light through their own quiet, needing nothing from us and taking nothing away. Their distance is not a wall built to shut us out. It is only the width of a universe that is larger than any single place within it. The far galaxies do not recede in sorrow, and they do not leave a wound. They drift, gently and evenly, into their own solitude, as they always have, as everything far always has, since long before there was anyone here to watch. And what we can reach is more than enough. Our own bright island, the galaxies bound to us by gravity, the hundreds of billions of stars of our home, and the worlds that may turn around them, this is a kingdom, not a scrap. It will hold any mind in wonder, for as long as there are minds to wonder and stars to shine. We were never meant to touch the whole of the cosmos. We were only ever meant to look up, and to let the far lights be far, and to find that the near light, the reachable light, the light that stays, is a fullness beyond any need. The unreachable universe is a gift of scale, not a deprivation. It is spaciousness, not absence. Perhaps that is the deepest comfort in the whole quiet fact. The universe is so enormous that most of it lies forever beyond our reach, and this enormity asks nothing of us at all. There is no task in it, no striving, nothing to be crossed or conquered or caught. The far galaxies do not need to be reached. They are complete in their distance, beautiful in their farness, perfect in the way they ask only to be seen. We can set down every wish to arrive, every ache to close the gap, and simply let the cosmos be as wide as it is. There is a great rest in that letting go, in accepting a universe too large to hold and finding it, somehow, exactly enough. So let the far galaxies be far now. Let the great shell of unreachable light hang gently in the dark, beautiful and distant and harmless, needing nothing from you. Let the horizon of reach rest where it rests, ages upon ages away from anything that could ever touch you. There is nowhere the universe is asking you to go, and nothing it is asking you to catch, and nothing missing from the small, bright island that is, and always will be, yours. Let the enormous calm distances widen slowly in the dark, far away and untroubled, carrying their old light through the quiet. Let the numbers soften and fade, the 97%, the 2 trillion galaxies, the 46 billion light-years, until it is only a gentle sense of a universe larger than any reaching, and a home smaller and nearer and entirely enough. Let the whole boundless machinery of expansion and horizon and fading light grow distant and still in your mind. Let your thoughts grow slow and wide and unhurried, like the space between the galaxies. There is nothing to reach for tonight. There is nothing to close and nothing to cross, and nothing you have failed to arrive at. There is only the far light, asking nothing, and the near light, holding you, and the deep and spacious quiet of a cosmos content to be as large as it is. Let your breathing slow. Let your shoulders soften. Let the day, with all its small reachings and small distances, drift gently away, far and harmless, like a galaxy easing past the edge of sight. The universe is under no obligation to be reachable, and neither are you tonight. You have only to rest, here, on the small bright island that stays, beneath a sky full of far and beautiful light. Let the far lights be far. Let the near quiet hold you. Let the great distances need nothing from you, and give nothing but their gentle, ancient glow. Sleep well, and good night.